So we want to physically understand what's happening in this problem. We're starting with liquid water. It's below the temperature at which it vaporizes. So we first have to take the liquid water and add heat to get it to the transition temperature, or 100 degrees C. That's this step here. Heat water from 55 to 100 degrees C. We calculate this heat as a temperature change, mass times specific heat times delta T. Once the water is at 100 degrees C, we can vaporize it. So we're going to vaporize the water, liquid water at 100 degrees C, to steam or gaseous water at 100 degrees C. The heat for this process, a phase change, is mass times the delta H of vaporization. So the total heat is going to be the heat from step 1 plus the heat from step 2. So we're going to add the heat from step 1, the temperature change, to the heat from step 2, the phase change. And we note that we want our heat in units of calories. So we calculate our delta T from the final temperature minus the initial temperature, plug that into our equation. Mass from the problem, heat capacity of water in calories per gram degrees C. And we can check our units to make sure things are set up correctly. Grams cancel, degrees C cancel, so we have calories from heat 1. Grams and grams cancel, calories from heat 2. And we calculate out those values. Now that we have an answer, we can look at sig figs. 3 sig figs in this initial calculation for heat 1, and also 3 sig figs for this calculation. We note here that we can't go beyond the tens place because the last sig fig for this number is in the tens place. Here it is in the ones place, but we need to go by the tens place because this is our first uncertain decimal place. So our answer is 1.87 times 10 to the third calories. Note we have to use scientific notation in this example to express our answer with the correct number of sig figs.